Hi, this is the final time series project done by Dipanshu Jain and Abhir Sharma. So the objective of the data that we're dealing with over here is the closing price of Bitcoin from 27th April 2013 to 3rd of March 2018, and it's been taken from coinmarketcap.com, so the data can be verified from there. The goal of this final project is to predict the value of Bitcoin for the next 10 days. So essentially this is the daily data and we want to predict 10 steps ahead forecast. So let's look at how the data looks like. So as we can see, since this is a data that involves daily values of Bitcoins over the years, there are a lot of values in there. And from the visual analysis, we can definitely see an existence of trend, so which is obviously changing from here, and it's been a little more or less constant here. So there's an existence of trend and there is a definite changing variance, like if it suddenly increased there, and probably this is going to be difficult to model. There is no evidence of seasonality that we can see, and the behavior is mostly auto-regressive, and it's we could see some portion of moving average in this part. It's mostly auto-regressive. Let's see the ACF and PACF of the series. As we can see that there is a definite existence of trend, since there is a decaying pattern in the ACF, and there is no evidence of seasonality that we can see in the ACF. And now since there is trend in this series, we'll first try transformation, and then maybe we need to do differencing in order to make the series stationary, and only after making the series stationary we can go ahead and do further analysis on it. So we'll first try the transformation of the series. We'll use the box-cock search methods to determine the value of lambda that we will use for transformation. In our case, the lambda that we got was 0.33, and we used that to transform the series, and this is how the transformed series looks. As we can see, we have not yet been able to capture that trend in the series, so there is still trend over here, but the changing variance compared to this one has definitely been more stabilized. So this is, as we said, this is the ACF and PACF of the transform series, so we can still see a trend in there. So maybe we'll go and first difference the series to see whether we can have a transformed series, stationary series or not. So this is what the ADF test suggests for this transformed series. So since we're getting a p-value of 0.9838, which is greater than 0.05, it means that the series is not stationary and we cannot reject the null hypothesis. Now we did the first differencing, and this is what the ADF test for the differenced series looks like. So we get a p-value of 0.01, and the alternative hypothesis is the series is stationary, so we can definitely reject the null hypothesis in this case. And this is how the ACF and PACF of the differenced series looks like. Now as we can see, there is significant autocorrelation in the series, and there are very many significant lags in the series. So going forward, so these are the lags that are significant, and PACF also has a lot of significant lags. So we'll first go and check with EACF and BIC tables as to what the candidate models can be. So this is how the EACF of differenced series looks like, and we can definitely have a vertex right in the starting point over here. So we'll get 0 0 model, 0 1 models, we'll even get 1 1 model, and this would be pushing it, but we could have gone for 0 2 and 1 2 models, but I don't think that that'll help us in this case. Let's see what we get with the BIC table. This is how the BIC table looks like. Now, BIC table always suggests going for big models, and this is what it's suggesting right now. So we have an AR component at lag 11 that has a lot of support. We could have gone for 4, but this doesn't have a lot of support, and similar is the case with lag 6. So henceforth I'm going with lag 11 over here. And for the MA component, the contention is between 6 and 11, but as we can see that the support seems to dwindle over here, so we'll go with lag 11 for this case. So it's essentially suggesting us an 11-1-11 model, which is a huge model to put in. But let's see how all the candidates model lines up. So what we have considered are all these models. So 313 is essentially an ARIMA model with an AR3 first order differencing and an MA3 component, and similarly an ARIMA 212, ARIMA 112, ARIMA 111. Model.011 is ARIMA 011 and 010, and now this is 5112 and 516. So this is how the AIC and BIC of models that we have considered. We have also considered GARCH models, but I'm not including them here. So there we go. This is how the AIC and BIC line up. And as we can see that they give us different results. So these are the GARCH models that I was referring to: M.11, M.01 and M.10. Similarly M.10, So these are the GARCH models and they don't have a BIC score. So essentially, since these are giving us different results, I am going to stress more on the significant coefficients part of the model. So what we've done is we have essentially checked coefficients of all these models and gone for the model that had the most significant coefficients, which was a model 212. Now as we can see, AR1, AR2, MA1, MA2, all these are highly significant. So the p-value is less than the smallest possible value that we can get. In all other models, we were not getting similar results. So for instance, just to take an example, in this bigger model 11-1-11, we had, out of the 11 and 11-22 coefficients, we had just barely 3 significant coefficients. So that suggests that we are over parameterizing the model and we don't need to go ahead beyond a 212. So we did go with a 313, but again, so the third coefficient became insignificant. That's why we left and ceased our race with 212. As we said that, I'm sorry, all these coefficients in the model are significant, and henceforth this seems to be a good model to go forward. Now the residual analysis for this model. This doesn't look very promising, but among all the models that we had, based on the balance between the significance of coefficients, the AIC and BIC scores, as well as the residual analysis, this is what we have come up with till now. We are still focusing on getting a better model that we are trying to investigate. But coming to the residual analysis part of it, we can definitely see changing variance in the time series plot of residuals. The histogram looks symmetric around mean 0, but the range is something that we should take into account. It's going from -5 to 5 instead of -3 to 3, and there is significant autocorrelation left in the series, and the normality of residual also does not look very promising, and the same is reiterated by the junk box test. That is, there is significant correlation in the series. But having said that, this is a very huge series and there are a lot of data points, and the models that we've considered till now, which have been more than 10 or 15 models, and as I said, that this is the best that we've got till now. So I'm going ahead with this, and we'll check for the forecasts from this model, and meanwhile try and get a MASE value, and from there on. But we are still investigating more models, so I'm still trying to get a better model for this. Now let's see how the forecasts look. So this is the forecast with ARIMA 212 model, and now as we can see that the forecast looks very similar to our last few values, and we'll check what those values are. And in our case, it's more or less matching up to the first 4 or 5 values, and then the error component seems to go up. But as I can see, the forecast from this 212 model look promising, and in the end, as I said, that we are still investigating more models, but this is the MACE value that we've got, 3.69, and now this value can definitely go further down if I consider a general trend. But having said that, since this is such a tricky series to model, and there's so much going on inside this because of so much data and different behavior in the series present locally, that it's difficult to model everything and trying to capture everything. So this is the maze value that we've got till now, and as I said, we're still working towards it. So this is what we have from the presentation for this final project. Thank you for listening.